Before we prove Theorem 13, it is absolutely essential that you have a thorough understanding of what Theorem 12 is about, because you're going to need it in order to prove Theorem 13. Now, what does Theorem 13 actually say? It says that if you have two triangles which are similar, then their sides are proportional. Now, drawing the diagram does help. So here's two similar triangles. You'd have met this in second or third year. And similar triangles, what do you know about similar triangles? The ratio of corresponding sides are equal, i.e. if you take AB and you divide it by its corresponding side, DE, this will equal to BC divided by its corresponding side. So this is what you're trying to prove. So we already know from theorems 11 and 12 that there's 5 areas that we have to address when we're proving this. The first area is diagram, which we've already done. The second area is given, then the need to prove, then construction, and finally proof. So the next thing is, what are we being given? And if you read the question, it's very simple. We've been given two similar triangles. So that's what we've been given, two similar triangles. And what do we know about similar triangles is that we know that corresponding angles are equal. So we state that that's an easy set of marks. What do we need to prove? Well, we have to prove for similar triangles that the ratio of corresponding sides is actually equal. So all we've got to do is copy out this section here and write it down. Again, easy marks. This is what we need to prove. Now, when it comes to the construction, you can superimpose your construction using different colours onto the original diagrams, or you can do separate diagram. That's really up to you. I've chosen to do separate diagrams. Now, the proof of this is we need to make this look like theorem number 12, which means we want this triangle inside this one. We want to construct this triangle on top of this one, where D is taking the position of A. So in order to do that, we have to, first of all, assume that ABC is bigger than DEF. Next thing is we need to mark a point X on the line AB, where A to X is equal to D to E. So we do that. And then we're going to mark a point Y on AC, such that the point Y, which is going to be here, or the point Y, has a distance from A equal to the distance DF. So here we go. So we've now, by construction, AY is equal to DF, and by construction, AX is equal to DE. We're then going to join X and Y up, and that should be the same as EF. Now we need to prove this. We need to prove that AXY is congruent to DEF. And this is how we're going to set about doing it. Now we need to argue why it is. Well, it's very simple. This side here is exactly the same length as DE, and that was done by construction. This angle here is exactly the same as D because it was given in the question. Corresponding angles are equal. AY is equal to DF. This was done by construction. So what we have congruency by side, angle, side. So we have congruency by side, angle, side. So that was easy enough. What else do we need to look at now? Well, we need to look at these two angles here. And what can we say about these two angles here? Well, we're going to say they're equal. I mean, they look the same, but we do need to actually argue it. So let's argue it now. Well, because the triangle AXY is congruent to DEF, it means that these two angles are in corresponding positions. and therefore consequently the angle at x is equal to the angle at E. But we also know that from what was given in the theorem statement, that the large triangle and the small triangle are similar, and therefore angle B is equal to angle E as given in the question. Well, if x equals E and B equals E, then this means that the angle x must equal the angle B. And we've formalized it here in writing. Now, I wonder if you spot the obvious now. Well, if this angle and this angle are equal, they're f angles. And if f angles are equal, then these two lines are parallel. So we now know that xy is parallel to BC. And the reason why it's parallel is because we've got f angles at x and b, which the technical term for those f angles is corresponding angles. So if corresponding angles are equal, then we have parallel lines. Now, because we've got parallel lines here and here, we've now created the scenario for theorem number 12. So therefore, we can now say that the ratio of corresponding sides on the left-hand side to the right-hand side are going to be equal no matter what combination we do it in. So we've got a to b divided by a to x must be a to c divided by a to y, and that is as a result of us proving theorem 12. Now, what else do we know? Well, we know that AX is DE by construction, and we know that AY is DF by construction. So that now means where we have AX in here, it can now be replaced by DE, and where we have AY in here, it can be replaced by DF. So we now get this line. And as you can see, that's 2/3 of what we're trying to prove done. It's this one and the end one. Now line 7 is quite simply, similarly, you can say that BC to EF is also equal to AB to DE. You don't have to formally prove it, but it's going to be the same sort of mathematics. And because you can now, once you've got a pair, you can do the similar bit, and then you can actually say, well, therefore, this is now true, proof follows. And that's the end of Theorem 13. Please study the YouTube video. Don't forget, when you're going back over to revise using the YouTube videos, you can pause at any point and advance yourself and then use the YouTube video to check to see whether you've got it right. Try not to memorize it, try to reason it. It's better to understand the proof than to memorize it.